Now we are going to see a new center whose name is Incentre. Okay, I want to tell you where the point of intersection of internal angle bisector, okay, is known as what? Incenter of a triangle. Means I said when the internal bisector of angle meets at the point I, and this point is known as what? Incenter. Okay. So we will find the coordinate of this incenter x comma y. Okay. This is our internal angle bisector. Where the angle bisector meets, that point of intersection is known as incenter. Understand? So suppose this is the triangle whose vertices are x1 y1, okay, and the second vertex x2 y2, and the suppose the third vertex is x3 y3. Okay, and I want to find this I. For finding this I, what I am doing is, suppose this is your D, this is your E, and this is your F. Okay, and first of all we will try to reach at I. Sir, how we can reach at I? For reaching at I, you should find the coordinate of D, this D. How, sir? The coordinate of D, if you suppose if you find the coordinate of D, in that case you can get the ratio of DI and AI. Okay, and if you find the ratio of DI and AI, then you can easily find the incenter I. Understand? So now, since you can see this is the vertex A, and I am doing what? On opposite of this vertex is, suppose the length is A. Okay, this is the only standard notation. Opposite of this B, suppose the length of AC is B. Okay, and opposite of this third vertex is, suppose the length is C. I think you are clear. Now I want to find the incenter I. Okay, for finding incenter, let us try to find this coordinate D, the point D. I will find the coordinate of point D. Okay, for finding coordinate of D, what I will do? You know, AD is the bisector of angle A. AD is a bisector of bisector of angle A. Okay. If AD is the internal bisector of angle A, therefore you have AB upon AC, which is equals to BD upon DC. Okay, because you know the angle bisector theorem. So we can write here AB upon AC. The ratio is C ratio B. Understand? It means we find what? This D is dividing the line BC in the ratio of C ratio B. Okay. So we can get the coordinate of D. How, sir? So for the coordinate of D, you can see this is the internal division of side BC in the ratio of C ratio B. So we can write the coordinate of D also. What is the coordinate of D? So for coordinate of D, we will take the formula of internal division. Okay. So now this is the Cx3 plus Bx2. What I will write? The coordinate of D will be Bx2 plus Cx3 upon B plus C, and By2, similarly By2, okay, By2 plus Cy3 whole upon B plus C. Understand? So we got the coordinate of D, and if you find the coordinate of D, now you will also try to finding the ratio of DI and IA. How to get the ratio? So far you can see this triangle. Which triangle? I'm making here triangle. Suppose this is your triangle. Okay, and now suppose this is your triangle. Mind it, this is not a right angle triangle. Okay, it is looking right angle triangle, but it is not a right angle triangle. I will make like this. Okay, and now here it was what, BI, and this was your D, and this was your A. Okay, you can see that this BI or BE, this is also a internal bisector of angle B. If angle B having internal bisector, that is a BI, okay, the line segment BI is the internal bisector of angle B. So we can again use the ratio of BD upon BA, which is equals to DI upon IA. Okay, so now from here you are finding the ratio DI upon IA, that is equals to BD, and we need to find the BD. What is the BD? Don't say, sir, the BD will be C, because here C ratio B is the ratio of BD upon DC. Okay, and what is the IA? Can you find IA? Okay, so I will write here कि sir कि this DI, can I find this DI? Okay, I have written something uh, BD upon BA, and we have BA, and BA length is C. It means now I will find only BD, the length BD. Okay, how to find the BD? If you solve this BD, then you will get the length of BD is, the length of BD will be AC upon B plus C. Now you are thinking, sir, how to get this AC upon B plus C? Okay, so you can do what? You have a ratio BD ratio DC, that is a C ratio B. Okay, and now BD ratio DC, you have a C ratio B. In place of DC, you can write what? A minus BD. Okay, and after cross multiply, you can very easily get the value of BD, and this value will come AC upon B plus C. Understood? So now here I want to put DI upon IA, that is coming AC upon B plus C and whole by C. Now this CC cancel, and finally I got A upon B plus C. It means I got DI upon IA ratio, which is coming what? A upon B plus C, means कि this IA is coming B plus C, and this is your A. Understand? Now we will try to find this coordinate uh, xy. So I will find the coordinate of Incentre. How, sir? You can see that this I is dividing the line segment AD internally in the ratio of B plus C ratio A. So I will take M B plus C as a M and x2, and you have the coordinate of D here. Okay, so I will write for in center we can write x equals to b plus c into what? This x2, mx2. In place of x2 is this complete, means bx2 plus cx3 whole upon b plus c. Okay, plus a into x1. So x1 is already x1, Okay, you can see A into x1. So whole upon B plus C plus A. Finally, I got this B plus C will cancel. And the x coordinate of the incenter, we are getting A x1 plus B x2 plus C x3 upon A plus B plus C. Okay. So now therefore you got x, and similarly when you will find y, then b plus c means m y2 in place of y2 is this term. So I will write b plus c into bx2 plus by2 plus cy3 whole upon b plus c and plus a into y1 whole upon b plus c plus a, and now therefore I got y equals to a y1 plus b y2 and plus c y3 whole upon a plus b plus c. So therefore we got the incenter of a triangle. Understood? So what is the incenter? Once again I am repeating. This is the point of intersection of internal bisector of angle. Understand? And here you can see the internal bisector of angles are meeting at I. So this I will known as the incenter, and we found this one. Understand? So now I am going to find Excentre. If you want to note down, then do it fast. Okay, now we are going to discuss our next topic, that is Excentre. Before starting Excentre, I want to say you कि Excentre is the point of intersection of two external angle bisector and one internal angle bisector. Understand? So here you can see, suppose there is a triangle ABC whose one internal bisector I will take. Okay, the internal bisector, suppose this is our internal bisector I am taking, and two external bisector. So here you can see this is your B, okay, and I am taking this external bisector, and from here also. Okay, now this is all meeting each other at point I1. Understand? So now here will be three Excentre. How? You can say कि one internal bisector I have taken and two external bisector I have taken B and C. You can take another Excentre, that is a I2, and another Excentre that will be I3. Okay. You can say कि if I will take this angle, okay, which angle? I want to take angle C. This is our internal, and take two external. Okay, now here you can see this is our, I want to write here. Okay, this is the our external bisector. So we will get one more point here. Okay, and similarly I will take another external bisector, that is now B, and from here I want to take, okay, and this is our external bisector of angle C. So finally you are getting here is the I2, this one is I2, I3, and there is a I1 also. Understand? So there is three Excentre is possible. Okay. Now first of all I will try to find first Excentre. Okay. Now let us find. Before starting the Excentre, I want to tell you कि Incentre and Excentre both are harmonic conjugate. Okay, What is the harmonic conjugate? I told you in the last lecture. The harmonic conjugate, suppose there is 2 points P and Q, okay, which divide the line segment joining AB internally and externally in the ratio of M ratio N. Okay, then the points P and Q are known as what? Harmonic conjugate. Understood? So now here, suppose this is our point D. Okay, already we had found here this D. Okay, and suppose this is RI. Why I am taking? Because it is our internal angle bisector. Okay, so Incentre will be here, and you know we have already found what? We have already found this ratio, DI ratio and AI ratio. What is the DI ratio? You have A and B plus C, means this I divides this AD internally in the ratio of B plus C ratio A, and also you have the coordinate of D. You have found that is a Bx2 plus Cx3 upon B plus C, and a By2 plus Cy3 upon B plus C. Okay, so this I1 I want to find Excentre. Okay, so therefore this I1, for I1 what I will write? Yes, this is our x comma y, and x equals to B plus C into, this is now, suppose this is your x comma y, okay, and D is the x2, suppose D is the x2. So I will write Bx2 plus Cx3 upon B plus C, okay, minus A into, that is x1 whole upon m minus n, that is a B plus C minus A. So finally you can see this B plus C will cancel, and I got x equals to minus A into x1, okay, plus B into x2 plus C into x3 whole upon minus A plus B plus C. Okay, so now you can see the students, we got the abscissa of first Incentre I1. Okay, similarly I will find y equals to what? Minus ay1 plus by2 plus cy3 whole upon minus a plus b plus c. Okay, so now I got the first Incentre I1, and if you want to find this I2, for this I2 what you will find? Yes, you will get I2 equals to ax1 minus bx2 plus cx3 whole upon a minus b plus c, and ay1 minus by2 plus cy3 whole upon a minus b plus c. This will be our second Excentre. Okay, okay, this Excentre I am talking about. Understand how to get? In place of x1 y2, you can replace this point x2 y3 and x3 y3, you can get I2 and I3. Understand? And similarly, if you will find I3, it will be now what? Ax1 plus bx2 minus cx3 whole upon a plus b minus c, and ay1 plus by2 plus cy3 whole upon a plus b minus a. So this is our three Excentre we found. Understand? So finally, today lecture you got what? There's three types of centroid, three types of center. The first one was centroid, the second I got Incentre, and the third was Excentre. Okay, so dear student, I think you understood. Now let us discuss our next point, that is the name Orthocentre. What is the Orthocentre? Okay, for Orthocentre, what is the Orthocentre? So students, I am telling you, the point of intersection of altitudes is known as the Orthocentre. Okay, what? The point of what I said? The point of intersection of altitude. Suppose this is your triangle, okay, and its altitudes are, suppose this is your altitude, okay, and now this is A, B and C, okay. Now suppose this is D, which is right angle, E is also right angle and F is also right angle, and this will known as the orthocenter. You can represent by S or O, okay, no problem. This is our orthocenter. Okay, how to find this coordinate? How will I find the coordinate? So dear student, for finding this coordinate, I am telling you, first of all, you will have the coordinate of x1, y1, x2, y2 and x3, y3. Okay, you can easily find the slope of this BC. Okay, and the perpendicular slope of AD, you can also find the slope of AD. Okay, like that you find the slope of AC and it's a perpendicular, you can find the slope, and then you can find what, this equation, the equation of AD and the equation of BE also, and solve these two equations and you can get very easily what, orthocenter. Okay, now our next center whose name is circumcenter. I'm going to telling you circumcenter. Okay, circumcenter. What is the circumcenter and how will I find? The circumcenter, it is saying the point of intersection of perpendicular bisector, where the perpendicular bisector meets to each other, then point of intersection is known as what? Suppose this is our perpendicular bisector and this is our perpendicular bisector and this is your third perpendicular bisector. Understand? Okay. Now there is three perpendicular bisector which meets at the point C. Okay, and this point is called what? Circumcenter. And already in last video I am telling you how to find the circumcenter, the coordinate of circumcenter. Okay, and more information I want to tell you कि in circumcenter the circle will passes through its vertices. Okay, circum will passes through its vertices, and this circle is known as circumcircle. Understand? And here the radius will be known as, suppose this is ABC and here CA, CB and suppose this is a triangle ABD, okay, and the CD, this is known as the circumradius. Understand? So you know to finding circumcenter, okay, how to find the circumcenter also. Okay, now I'm going to tell you some important properties of centroid, orthocenter, circumcenter and incenter. Okay, now see, the first property is what? Ki this centroid, G divides the orthocenter and the circumcenter in the ratio of 2:1. Suppose they have given you orthocenter and the circumcenter, then find this centroid, then you can easily find it is dividing in the ratio of 2:1. Okay, now suppose centroid given, orthocenter given, and you have to find it's a circumcenter, then you can easily find this one. So therefore if two data you have, then you can easily find the other point, yeah, other center. Okay, now let us see the another property, the property number 2. If suppose the centroid of, sorry, the suppose the orthocenter of ABC is O. Okay, then orthocenter of, then the orthocenter of this triangle, triangle AOB, will be what? C. This C will be the orthocenter. Okay, and the orthocenter of triangle AOC will be B, and the orthocenter of triangle BOC will be A. Now you can find the question very easily. Okay, now if you want to note down, please do it fast. Okay, now suppose what I said here, K orthocenter of this triangle AOB will be C, and the orthocenter of triangle AOC will be what? B, and similarly the orthocenter of O triangle OBC will be A. Understand? So now let us see another properties. Suppose there is a any right angle triangle. Okay, right angle triangle. Fine. Then suppose the vertex B is making 90°. Okay, and this is your ABC. So, and here you can see this vertex B is making a 90°. Okay, so this vertex B is known as what? Orthocenter. This is known as orthocenter. Now you will say, why sir? Because your definition of orthocenter is when altitudes meet each other, then point of intersection of altitude is known as what? Orthocenter. You can see here the altitude is meeting at B, here the altitude meets at B, so the point of intersection of altitude you can see B, so finally B will be orthocenter. Okay, now again in same case, suppose there is a right angle triangle. Okay, and they are saying the midpoint of hypotenuse, the midpoint of hypotenuse will be what? Circumcenter. This will be our circumcenter. Circumcenter. Now you will say, sir, how? So for finding this circumcenter, what I will do? For the case of circumcenter, for case of circumcenter, the circle passes through its a vertex. Okay, so now, okay, right, I want to make the figure, correct figure. Okay, fine. Circle passes through its vertex. You can see the vertex of this triangle ABC, and in previous classes you have done ki if it is a right angle triangle, it is a making a right angle triangle, in that case this AC will be diameter, and if AC will be diameter, then this point will be what? Center of the circle, and it is the midpoint of what? Diameter. Okay, and therefore we can say ki this diameter is also a hypotenuse. It means I got what? Ki circumcenter is the midpoint of hypotenuse. I think you understood. Now let us see another property. Suppose there is a any isosceles triangle. In case of isosceles triangle, now it will happen, suppose this is our isosceles triangle, triangle ABC. Okay, and now suppose this is equal, and now this is your D. In case of isosceles triangle, this centroid, orthocenter I and C, will come on the same line. This will come on the same line, on this line. Where? Here G O I C will come on this same line. Understand? You will say how? Because this AD may be median, it may be median, and if AD is the median, in case of, if AD, suppose AD is the median, okay, then you know कि on the median there lies centroid. Okay, so on median the centroid will lie on the median. Understand? Now suppose AD is the altitude. If AD is the altitude, okay, now in this case कि on altitude the orthocenter will come. Okay, orthocenter will come. Now the third, if AD is suppose angle bisector, angle internal, I will say internal angle bisector, in that case where Incentre will lie on internal angle bisector. Okay, here Incentre will come. Okay, and if suppose ki AD is what? Perpendicular bisector. Okay, in that case I will say कि circumcenter, यदि ये perpendicular, if it is a perpendicular bisector, in that case we will get what? We will get circumcenter. Understood? So therefore I will say कि if the triangle is isosceles triangle, okay, in that case GOIC will lie on the same line. Fine. Now suppose the triangle is equilateral triangle. In case of equilateral triangle, suppose the triangle is equilateral. A x1 y1, B x2 y2, and C x3 y3. In case of equilateral triangle, the GOIC will be coincide on the same point. Okay, means GOIC will lie on the same point, means centroid, orthocenter and incenter and circumcenter will lie on the same point. It will be coincide to each other. Suppose they are giving centroid and they are asking to find orthocenter. So directly we will say, suppose the centroid is 2 3 coming in, okay, and in case of equilateral triangle you will say orthocenter is also 2 3, incenter is also 2 3, and circumcenter is also 2 3. Okay, I think you understood. Please note. Okay, now the next property is कि for case of, suppose the triangle is acute angle triangle, acute angle triangle. In case of acute angle triangle, orthocenter will lie, orthocenter orthocenter will lie inside the triangle, this is the next property. Okay, if suppose the triangle is acute, in case of acute angle triangle, the orthocenter will lie inside the triangle. Okay, what is the acute angle triangle? Suppose the vertex is ABC. If AB square plus BC square is a greater than AC square, yes, CA square, in that case the triangle is called acute angle triangle. Understand? And if AB square plus BC square is the less than AC square, in that case the triangle is called obtuse angle triangle. So for case of acute angle triangle, orthocenter will lie inside the triangle. If you want to write, please do it fast. Okay. Now suppose the triangle is obtuse angle triangle. In case of obtuse angle triangle, suppose the triangle is obtuse angle triangle. What is the obtuse angle triangle? If AB square plus BC square becomes the less than AC square, in that case the triangle is called obtuse angle triangle. Okay. In case of obtuse angle triangle, the orthocenter will lie outside 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 of the triangle. The orthocenter will lie outside of the triangle. Okay. Now, I think you understood. Suppose the vertices of triangle is given 0, 0, x1, y1 and x2, y2. Suppose the vertex is given 0, 0, b, x1, y1 and c, x2, y2. Okay. In case of the vertex 0, 0, b, x1, y1, c, x2, y2, in this case, the value of orthocenter, the coordinate of orthocenter will be what? K into y2 minus y1 comma minus k into x2 minus x1. Okay, what is this? This is our orthocenter. Understand? And what is the k? If we'll say, if what is the k, so the k will be, the value of k is x1 x2 plus y1 y2 upon x1 y2 minus x2 y1. Okay, it means suppose your three vertices are given 0, 0, x1, y1 and x2, y2. In this case, the orthocenter will be this R. Understand? So you can see this all property. This is a very important property. Please note down if you want. Okay, what we have seen, the first property here I have shown कि in the centroid will divide the orthocenter and the circumcenter in the ratio of 2:1, and orthocenter and centroid and circumcenter will be collinear. Understand? Second, I said कि if suppose there is a triangle ABC and whose orthocenter is O, then orthocenter of triangle AOB, triangle AOC and triangle OBC, okay, will be A, B and C. Understand? Now next I told, suppose there is a right angle triangle. In case of right angle triangle, the vertex of 90° will be our orthocenter and the midpoint of circumcenter will known as the circumcenter. Midpoint of hypotenuse is known as the circumcenter. Next what I tell, कि in case of isosceles triangle, triangles should be isosceles. Okay. In case of isosceles triangle, okay, the GOIC, centroid, orthocenter, incenter and circumcenter will lie on the same line. Okay, here I said what? If triangle is equilateral triangle, and in that case the centroid, orthocenter, incenter and circumcenter will coincide to each other. Okay, and now I told here, if triangle is a acute angle triangle, meaning AB square plus BC square is greater than the AC square, in that case the orthocenter will lie inside the circle. Where will be the orthocenter? Inside the triangle. Okay, and as well as I said, if triangle is the obtuse angle triangle, in case of obtuse angle triangle, the orthocenter will be outside of the outside of the here I have written what? Outside of the triangle. Understand? And now here I told what? If suppose there is a triangle whose vertices are given then the coordinate of orthocenter will be k y2 minus y1 and minus k x2 minus x1, where k is the x1 x2 plus y1 y2 upon x1 y2 minus x2 y2. So I hope you understood this all the things. Okay, now let us continue the next topic. Now we are going to see the area of triangle. Okay, what is the area of triangle? Okay, for finding area of triangle, suppose there is any triangle whose vertices are a x1 y1, b x2 y2 and c x3 y3. Okay, now I want to find the area of this triangle. Okay, so this is a very easy and already you have discussed in class 10th or previous classes. The area of triangle will be equals to 1 by 2 what x1 into y2 minus y3 plus x2 into y3 minus y1 and plus x3 into y1 minus y2. This is our area of triangle ABC. Fine. But how to find this area of triangle? Let us discuss. The topic is the area of triangle. How to find the area of triangle. Understand? So, okay, fine. Area of triangle. We are going to discuss area of triangle. Okay. Now suppose that this is our y-axis and this is our x-axis. Okay. And I want to find the area of triangle ABC. Okay. Suppose this is your y and this is your y dash and this is our x and x dash and this is our origin. Okay. If I say for finding the area of triangle, what I will do, let us see. Okay, all right. I am doing what? If first of all, okay, let us do something. Turn. Okay, fine. Now you can see here is a trapezium. The name is suppose STU. First of all, what I will do, I will find the area of this trapezium. Okay. Then I will find the area of this trapezium ATUCA. Okay. Then I will subtract the area of this trapezium BSUC. Okay. The final result we can get the area of triangle. Okay. Let us try to do. For the area of triangle ABC, what I said, we should find the area of trapezium, which trapezium? Okay, SBAT, SB trapezium, SBAT, AT plus I will do what? The area of trapezium, which trapezium? TA, TA, okay, CU, and then I will subtract the area of trapezium, which trapezium? SBCU, SBCU. Then only we can get the area of this triangle. Understand? Let us find. So for area of trapezium, you know area of trapezium. What is the formula? Yes, it is half sum of parallel sides into distance between the parallel side. Distance between the parallel side, parallel side. Okay. So here you can see the parallel side is a BS and AT. Okay. So now we will try to find the area of triangle ABC, that is the area of trapezium. Okay, let us find the area of trapezium, sum of the parallel height. Okay, 1 by 2, this is our y2 plus this is our height y1. Okay, into the distance between them. So till here OT is given x1 and OS is given x2. So the distance between them will be what? X1 minus x2. I will write here x1 minus x2. Okay. So now here I want to write x1 minus x2. Okay. Plus for this trapezium, I will find the sum of this parallel height. Okay, so now it is the 1 by 2. The parallel height is y1 plus y3. Okay, and into distance between them. So what is the distance between them? You can see till here the distance is x3 and OT is the x1. So I will write x3 minus x1. Okay, so here we can write x3 minus x1. And finally, we got these two trapezium. Okay, now what I will do, okay, all right, I will separate the trapezium BSUC. Okay, so the area of trapezium BS, I will write the sum of parallel side. You can see here is the y2 and here is the y3. Okay, now it is y2 plus y3 into the distance between them. The distance between them. What is the distance between them? Okay, we have to find SU. The complete distance is x3 and this is our x2. So I will write x3 minus x2. Okay. So finally I got the area of triangle after calculation. How to do? Let us see. What I am doing here, for area of triangle I am taking 1 by 2 as a common. Okay. Now do product here. So here x1 y2 minus x2 y1. Sorry, I want to write y2 x2. Yeah, x2 y2 first. Okay. Now plus x1 y1 here minus x2 y1. Okay. And there let us multiply here. I will write what? x3 y1 plus, yes, x3 y3 plus x3 y3. Okay, I multiplied here. Now minus x1 y1 and then minus x1 y3. Okay, and then we will try to find here. Yes, do product x3 y2, but it is the minus symbol. So I will write x3 y2. Now minus minus plus minus y2 into minus x2. This is now x2 y2. Okay, minus x3 y3. I will write x3 y3. You can see here, and minus minus plus x2 y3. And now I got what? You can see if something is going to be cancelled. What is this? X1 y1 x1 y1 cancel. Okay. Now here another term which is cancelled. 1 2 3 4, and here is the what? x3 y1. This is your x3 y1. Okay. Now another thing cancel. x2 y3 cancel. No, x2 y2 not cancel. Okay, yeah, you can see this x2 y2 is also cancelled. Now another term, yes, x3 y3 is a cancel. Here is a x3 y3 cancel, and we got what? This triangle equals to coming 1 by 2 into x1 y2 minus x2 y1, x1 y2 minus x2 y1, okay, and then x3 y1 plus x3 y1 minus x1 y3 we got, okay, you can see, and then I got x3 y2 minus x3 y2 and plus x2 y3, I got x2 y3, x2 y3. So finally we are getting the area of triangle. Okay, when you will solve this one, you will get what? The area of triangle ABC is equals to 1 by 2, and what is the common tail? You can see x1 y2 and where is the x1 common? Yes, this is x1. So you can see x1 common. Now I will get y2 minus y3. Here you can see x2 y1 and here x2 y1, yeah, x2 y3. So here is the common x2 and I will get y3 minus y1, and now similarly I will add x3 into y1 minus y2. So this is the very long process you saw to finding the area of triangle. If the triangle is given ABC whose vertices are given x1 y1 and x2 y2 and x3 y3, so we can find the area of triangle like this. Okay, now we are going to see again the area of triangle by using another method. Okay, please note down. Okay, now let us see area of triangle by another method, that is a Sarus method or Stiers method. Okay, what is the Sarus method? By Sarus method. Okay, or we will say Stiers method. What we are finding? We are again finding area of triangle ABC. Okay, let us see how to find the area of triangle with using this method. Okay, for finding the area of triangle, what I will do? Okay, let us change its color. Suppose the triangle whose vertex, first vertex is x1 y1 and second vertex is x2 y2 and the third vertex is a x3 y3, and I want to find the area of triangle this ABC. Okay, so for finding this area of triangle ABC, what I will do? Okay, I will write the area equals to 1 by 2, and in case of this I will write x1 y1, x2 y2, x3 y3, and then again I will write x1 y1. Okay, and now I will do what? The cross multiply like this, and this is your area of triangle will come. Okay, let us see. So now here you can see this is now 1 by 2 x1 y2 minus x2 y1, I will write, then x2 y3, x2 y3 minus x3 y2, x3 y2, then x3 y1 plus x3 y1 minus x1 y3 I will write. So this was the area of triangle. You can see this is the same formula, x1 y2 minus x2 y1 plus x2 in last, x2 y3 minus x3 y2 and then x3 y1 and minus x1 y3 it is coming. Understand? So now finally I got the area of triangle. Okay, by using Stairs method or Sarus method. Fine. So now we can also write this method like that, area of triangle ABC. Again we can write 1 by 2 into x1 y1, okay, sorry, x1 x2 x3, and then again I will write x1. Okay, because here I have written x1 y1, x1 x2 x3, then x1, so we can also write in horizontally. Okay now, and y1 y2 y3, and this is your y1. And now what I will do here, I will do the cross multiply, and then we can also get the same answer. The area of triangle, that is a 1 by 2 and x1 by 2 minus x2 y1 plus x2 y3 minus x3 y2 plus x3 y1 minus x1 y3. So this is the method for finding area of triangle. Understand? You have the another method to finding the area of triangle. I am telling you, that is the determinant method. Okay. Now let us see the next method, that is name is determinant method. Okay, how to find the area of triangle by determinate method? For this thing, first of all, what I will do, I will make a determinant. Okay, and the area of triangle ABC will be equals to 1 by 2. I will write here 1 by 2, and I will write the vertices x1 y1 then 1 and x2 y2 then 1 and x3 y3 then 1. Okay, now after this I will do what? I will expand this determinant, and you know the method of determinant, how to find the determinant. Already we have a video on your playlist, you can check. Okay, now again I am telling you, if I expanding along column 1. Let us expand along column 1. So if you expand along the column 1, you will get what? 1 by 2 into what? X1 into, this is delete. Now I got y2 minus y3, okay, minus x2 into, what I will write? Y1 minus y3. What is y3 plus y1? But wait, here is the minus x2 and y1 minus y3. We can do what? We can multiply this minus inside the bracket. And if we multiply, so it will be now what? This will be positive and this will be negative. And then x3 into, I will write x3 into, this is delete y1 minus y2. y1 minus y2. So finally you can see if this is again coming the area of triangle ABC by using the same formula. You can see here x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y3. Understand? So this is the three methods to finding the area of triangle. Understand? Now let us see another thing. It means you can find the area of triangle very easily. So now I'm telling you the another thing, the area of quadrilateral. Suppose you have to find the area of quadrilateral. Okay, for area of quadrilateral, suppose there is a any quadrilateral like that, and you want to find the area of this quadrilateral ABCD. Suppose the vertices are x1 y1 x2 y2, and suppose this vertex C is a x3 y3 and the vertex D is the x4 y4. Okay, and I want to find the area of quadrilateral. For finding the area of quadrilateral, what I will do, we can draw into two triangle like this, and I can find the triangle area of triangle ABC and the area of triangle ACD, and then I will add. But student, it will take more times. So I am giving you another method to finding the area of quadrilateral. Okay, chalo. Okay, all right. Let us see that method name is the Cyrus method. By using the Cyrus method, we can find the area of quadrilateral very easily. Suppose the area of quadrilateral will be 1 by 2, and suppose the vertices of any quadrilateral are given x1 y1 x2 y2 x3 y3 and x4 y4. Then you have to do what? Again you have to write x1 y1. Understand? For quadrilateral you have to write 4 vertices, then again repeat 1 vertices. Okay, like that also. For area of pentagon, hexagon, you will do like that. Understand? So what I will find this product, and now we can get the area of quadrilateral. How? Let us see. The area of quadrilateral will be the area of quadrilateral, that is area will come equals to 1 by 2 into, I will write x1 by 2 minus x2 by 1, okay, plus x2 by 3 minus x3 by 2, then x3 by 4 plus x3 by 4 minus x4 by 3 plus x4 by 1 minus x1 by 4. This will be the area of quadrilateral. Understand? So like that you can also find the area of pentagon or hexagon. Understand? By using the Cyrus method if the vertices are given. Now let us see the area of any polygon. If suppose there is any polygon and the vertices are given and you have to find the area. For area of polygon means any polygon you have and you have to find its area. Suppose the polygon having n sides. How many sides? N sides. Okay, n sides, and the polygons whose vertices are given x1 y1, x2 y2, x3 y3, like that. Vertices, vertices are suppose x1 y1, x2 y2, like that, xn yn, and I want to find the area of this polygon. Okay, for area of this polygon what I will do? The same method. Yes, you understood. Area of polygon will be equals to, I will write x1 y1, x2 y2, then x3 y3, then like that I will go xn yn, and then again I will write x1 y1, and I will do the cross multiply like this, and hence you can get the area of polygon. Any polygon you can get. Understand? So you are saying ki sir, I don't want to write in vertical, I want to write in horizontal. Okay, no problem, you can also write in vertically. How sir? Suppose the vertices are x1, x2, x3 dot xn, then you write x1, and the y coordinates are y1, y2, y3, yn and y1. In that case also you can get the area of any polygon after doing this thing. Understand? So this is the very easy to finding the area of any polygon. Understand? Now I'm going to tell you what is the properties of this triangle. Okay, but before the property I'm telling you the collinear. If suppose there is a 3 points and these 3 points are collinear. Okay, collinear. So for collinearity, suppose there is a 3 points a x1 y1, a x1 y1, b x2 y2, and the c x3 y3. These all the 3 points are collinear. What is the meaning of collinear? They are lying on the same line. In that case, you can see, suppose this is RA, this is RB, and this is RC. Suppose these 3 points are collinear. Okay. In that case, what I will do, we can find the 3 conditions for the collinear of 3 points. The number 1 condition, we can write that the area of triangle ABC will be 0. I will say the area of triangle ABC is 0. Okay. Why? Because if it is a collinear means it is a making a line. Or in that case, the area of triangle will come 0. Okay. Number 2, second number I am telling you, the slope of AB is equals to slope of BC is equals to slope of AC. The slope will be equals, okay, that is what is the slope of AB. If you want to write the slope of AB, then you will write what? Yes, it is now y3 minus y1 upon x2 minus x1 is equals to, yeah, slope of AB. Then slope of BC, that is a y3, sorry, this is the y2, y3 minus y2 upon, I have written here y3 again, this is the y2, okay, y2 minus y1 upon x2 minus x1 equals to what I said, y3 minus y2 upon x3 minus x2 is equals to the slope of AC, that is the y3 minus y1 upon x3 minus x1. The slope will be equal. Okay, and the third condition is, suppose the 3 points are collinear. In that case, the distance of AB and plus the distance of BC, it will equal to AC. By using the distance formula, you can see if 3 points are collinear or not. If you are getting any of them, like if you are getting the triangle ABC whose area is 0, in that case you will say that the 3 points ABC are collinear. Or if you find slope of AB or slope of BC or slope of AC all are equal, in that case also you will say the points are collinear. Okay, and again if you find AB plus BC equals to AC, in that case also you will say the points are collinear. So I think students, you understood this all the things. If you want to note down, please do it fast.